let's give you guys some more practice. But before I do, let me just quickly explain something to you first. Suppose you have some sort of gas trapped inside a container here. Let's just say it's air. Let's just imagine as air. Okay. If you push against this metal disc here, you're going to force all the air down. So here the volume. So here this is a volume here of the gas currently. If you force this down here, the volume will decrease. But then the thing is, the pressure goes up. The pressure increases. Pressure, roughly speaking, is the force acting on a certain area here. So in this case here, when you decrease the area, the pressure pushing on this container from the inside will go up. So it's a bit like you getting a bicycle pump and putting your finger on the nozzle at the end. If you force the air down, the volume here decreases, but then the pressure goes up. Whatever pressure means, okay. Hopefully your science teacher will explain pressure one day. But just roughly know that if you decrease the volume here, whatever pressure is, the pressure goes up. So it's similar to you getting an empty, let's say an empty bottle here. If you put your mouth, if you put it against your mouth and use your mouth to seal off the whole thing and blow into this really hard, the pressure goes up, whatever pressure means. Okay. Well, anyway, so here, hang on. So here's a question here. So the volume V of a gas at a constant temperature here. Constant temperature means the same temperature. So for example, let's say here this is at 23 degrees Celsius. If you force this down, it means over here cannot be, let's say 37 degrees Celsius. You cannot heat this up here. It has to also be 23 degrees Celsius. It has to be a constant temperature. Constant means same temperature. So you're not allowed to heat up this side here. So this side cannot be hotter than this side, or cannot be cooler than this side here. It has to be at a constant temperature. Okay, so hang on. So anyway, the volume V of a gas at a constant temperature is inversely proportional to the pressure. So whatever that means, let's just translate it to math. So here, so the volume V of a gas is inversely proportional to the pressure. So we can immediately jump to this. Now, once you're told this, you can remember you can imagine the graph here with lots of lines here. You should also imagine V equals a constant over P, or you can imagine as V with V here with this here. So as V increases, pressure decreases. If V decreases, then the pressure increases. Is that use one of these. Imagine these scenarios when you're given this here. Okay. So anyway, answer these questions here. Oh, question 3 is saying that find the relationship between between volume and pressure. What that means is express this as an equation. Okay, something like this, V here. Yeah. Well, anyway, press pause and have a go. Okay, so to do this here, well, we know that V is inversely proportional to the pressure. Question 1 saying what happens to the volume if the pressure is tripled? So now in this case, I would imagine it like this. V, inside your mind, visualize this. V pressure here. Now if the pressure goes up by 3-fold, okay, if you times this by 3, then the volume would decrease by, well, you would divide it by 3, or you can think of it as timesing by 1 over 3. So if you triple the pressure, then you're gonna the volume you're gonna need to divide the volume by 3. Okay. Question 2 is what happens to the volume if the pressure is increased by a factor of 7? So here again, visualize this. V here, pressure here, because it's an inverse proportional relationship. What happens to the volume if the pressure is increased by sevenfold? So if here you're increasing the pressure by 7 times 7 here. So here the volume would well you would need to divide the volume by 7. Okay. And question 3 here. Find the relationship between V and well, it's going to be this. Okay. Pressure here. So when you're told that volume is inversely proportional to the pressure, then you can jump inside your mind. You can jump to this. Now it's just a matter of working out the constant K here. So but then you're told initially that the pressure is 100. Okay, the pressure is 100. Well, normally they normally state the units after that. Pressure newtons meters squared. Okay, so well, don't worry about the units for the time being, and also volume should be meters cubed, but don't worry about the volume. Just look at the values here. When the pressure is 100, so you put this 100 into the P, and then you put this 3 into the V here, just in to find out the K. Okay, so this would be V is 3 equals K, and the pressure here is 100. So put it into here. So K, K equals 300. Okay. So our relationship is find the relationship. So V equals 300 over P. Okay. So this is our relationship. This is our answer to question 3. Okay. Question 4 is find the pressure that gives a volume of 8. So now we want to work out P when the volume is 8. So hang on. So put the 8 here into the volume here and work backwards to find out P. So 8 equals 300 over P. So times both sides by P, so that will be 8P equals 300, and then divide both sides by P. So P equals 300 over 8. So this here, well, you can jump to a calculator, or you can just leave as this. Okay.